Hello everybody in Earth Science, Mr. Douglas here. So today what I wanted to show you is a ways that scientists can use relative dating to be able to determine the age or the approximate age of specific layers beneath the Earth's surface. So the diagram you see on my screen right now, let's just make this a little bit bigger. So the diagram that you see on the screen right now is a one that shows 5 layers. Okay, we have layer A, layer B, layer C, layer D, and then this event E. Okay, and each of these layers occurred at a different period of time. So what we want to do is we want to look at let's put these layers in order from the youngest to the oldest. Now, actually, I'm going to change this right over here. I'm actually going to change this because I don't want to go from youngest to oldest. I want to go from the oldest, and then I want to go to the youngest layer. I made a quick decision right there to kind of change that up. So the oldest layer in this particular one. So when we look here at this document, right, we see that we have all the layers here. Now, the oldest layer would be where? Remember our law of superposition? The oldest one is always going to be found towards the bottom. So let's take a look right here and let's see what's going on. So which layer appears to be all the way down at the bottom or the furthest down? Now, if I'm looking here, there's 3 possible options. There would be like C, D, or B, right? But we can see something happened here that split D apart. So D is not going to be considered to be the oldest layer also because you can see D went through C and B. So because D went over those layers, it had to have occurred after them. Okay, so let's take a look. As of right now, the layer that appears to be the oldest layer to me right now would be C. And C is all the way down at the bottom. Now we can't see C over here because it looks like B slid down a little bit, that layer. So the oldest layer in this particular case, the oldest layer is going to be C. Okay, so now if we go to our next layer, okay, after C it should be pretty easy to figure out which layer came next. And I would say that after C came what? I would definitely say B came after that. So the next oldest layer would be B. And again, we know it can't be D because D is running directly through that layer. So now using that idea that this intrusion, or now eventually became an extrusion because you can see it exited out from the surface up here, we've gotten rid of C and we've gotten rid of B. So I'm just going to cross those out for a second just so we don't look at those anymore. Okay, so that leaves us with A, D, and E for our next layers to get to the youngest or the most recent layer, or the most recent geologic event. So if we're looking here, which layer would probably come next? And the next oldest layer for us in this case is going to be A. And why is it going to be A? Well, because remember, the layers build on top of each other. The younger layers are going to be the ones closest to the surface. And also, we know it has to be A and it can't be E and it can't be D because look, D runs through layer A, which means it had to have occurred after A was already present, meaning that D, on the other hand, has to be younger than A. So now if we take a look here, that leaves us now with 2 options. It leaves us with E and it leaves us with D. And in trying to figure out which one of those came next. So if we're looking here, the big difference here is that you can see D looks like it shifted downwards. So it looks like D shifted down. Now, how do we know that that could have happened first? Well, we know that had to have happened first because D made it all the way through to the surface to become an extrusion. So the next oldest layer, the next youngest layer would be D, and that leaves us lastly with E as being the youngest layer or the youngest event. And how do we know E is? Now E right here, just to give us an idea in terms of like what we're talking about, E is considered to be a fault. Okay, so that's a fault. Over here, this is our extrusion. Okay, and that's our extrusion. So the fault, let's just move this over here a little bit here. Actually, you know what? That right there is our fault. Okay, so the fault is going to break that apart. And that's why we saw the slippage coming this way of B, because this fault is breaking in that direction. Okay? So this is how you read diagrams in terms of trying to figure out exactly their age. So the big keys here are you want to look to see first, what is the layer of the events, right? Remember the oldest towards the bottom. And then you want to see, do any intrusions or extrusions run through a layer? If they go through a layer, that means they are younger than the layer that they went through. And then you want to check to see, are there any faults? Are there any slippages that occur? Remember, the fault is going to be younger than the layers of rock that it goes through, okay? Which is why in our case today, E was the youngest layer. Okay, so that wraps up our little talk here about being able to identify and correlate rock ages. If you have any questions, please put them down to the comments section in the Google Classroom page, and I'll get back to them as quickly as possible. Also check in on Google Classroom in one of our live meet sessions, or you can always send me an email or a message via the Remind app. I will respond back to you as quickly as possible. Hope you all have a wonderful day. Stay safe, stay healthy, and I will talk to you all soon. Bye.